Hello everybody, my name is Gita Somit. I am from VVIT College, CSCC, and today I am going to discuss about data structure seminar topic, and the topic is circular linked list. Let's discuss about it deeply. Before going into circular linked list, it is necessary to know what is meant by a linked list. So, in data structures, linked list plays an important role. So, as per the definition, linked list is a collection of nodes where each node consists of two paths. A linked list is a collection of nodes where each node consists of two parts. Here the first part is called the data part and the second part is called the link part. The data part consists the data value, i.e. it can be the numerical value or any value in the node, and the link part consists the address of the node. Address of the node that points the other node. And the link part is nothing but the part in the node which consists of the address in which this particular node points to the other node. So the linked list is generally represented in memory by using a self-referential structure. A self-referential structure is nothing but a structure pointer variable pointing itself is known as a self-referential structure. And there is a small example like struct node, opening the braces, into data and struct node next. Here the next is nothing but a structure pointer variable which stores the address of this, which points out again this structure variable node, and this is nothing but the representation of self-referential structure, and mainly most of the linked list are represented in this type. So this is about linked list, and let us see a basic example of a linked list. So here we can see that this is a collection of nodes. There are for example, let's take a 4 nodes having two parts. One is the data part and one is the link part. Here you can see that the first part, in the first node, the first part contains a 10, where 10 is a data part, and 200 is the link part, which is the address of the next node. As the next node is 20, the address of the 20 is 200. So 200 is stored in the link part so that this node points out to the this node, and 300 and the 20 node has next part has 300, which points out to the third node having a data value 30, and this third node has a link part 400, which points out to the fourth node having a data value 40. And when the linked list is completed, the next part of the last linked list is stored as a null value, and generally we represent we take head part pointing the first variable, and we move our head part by copying into a temporary variable to perform various different operations. The different operations we'll see in the coming slides. And so this is a basic idea about what is meant by a linked list. So as we have learned about what is meant by a linked list, now we will see about what is meant by a circular linked list. Generally, linked list are of 4 types based upon the types of node and their representation. They are single linked list, circular linked list, double linked list, double circular linked list. So in the 4 types, this circular linked list is a type of a linked list. So coming to the definition, a circular linked list is a type of a linked list where the last node points out to the first node. Here you can see when we see a linked list, here each node points out the other node. The first node points second node points the third node points the fourth node. Whereas the scenario is not same in the circular linked list. Here the first node points out the second node and second node points out the third node, whereas as third node being the last node, it points out again the first node. In general, circular linked list is also represented by using a self-referential structure. The only change between the circular linked list and single linked list is nothing but the last node always point out to the first node only. So the first node address is stored in a head variable, and this is the basic representation of circular linked list. So there are different operations of circular linked list having like insert, delete, create, traverse, merge, swap, etc. So there are several operations performed on linked list. In this topic, let's discuss about the insert operations. Insert operations generally they are three types. They are insert at beginning, insert at any position, and insert at the end. So for these three types of insertion operations, there are different algorithms and different approaches followed. So let us see what are those different algorithms and different approaches for each of the operation. So let us begin them. The algorithm for insertion at beginning. So to insert a node into a circular linked list in beginning, we follow this following algorithm. So it is nothing but the step one is nothing but create a node with a given value. We need to create a node by using a malloc function which creates a block of memory, and we need to pass a data value into it. And the second step is nothing but we need to check whether the linked list is already created or empty. If the linked list is empty, then we need to set our new node address as to the head, and node of next is nothing but head. We need to assign a head variable to the linked list, and we need to assign head as head is null here. We are keeping node of next is head. So this is step 3, and once again we will discuss about it. If the linked list is empty, we need to set the node address as a head address. So there's nothing but we are pointing the head variable to the node, and we are changing the node of next to the head. Head is nothing but as if linked list is empty, we need to set head equal to null. So the next part of the node will be the null variable. This is scenario when the list is empty. That is nothing but it is the first node we are creating. If the list is not empty, that means if the list contains some elements, some nodes, then what is the scenario we need to follow? So that is explained in the step 4. If it is not empty, if the list is not empty, then define a node temp pointer variable and initialize with head. As head always points out to the first node, we cannot change the head variable address. So for that instance, we create a temporary variable and we pass a head address to the temporary variable. Head address is nothing but the address of the first node. Keep moving the temp variable to its next node until it reaches to the last node. Because since it is a circular linked list, as we have seen here, circular linked list is nothing but the last node points out to the first node variable. The last node should point out to the first node. As when we are creating a variable, when we are creating a first node here, when we are inserting a node at the beginning, there is a necessary to change the last node address pointing to the new node, as it is being the beginning of the linked list. So for that, we take a temporary pointer and initialize with the head and move this temporary pointer until the last node until we reach to the last node. So that condition is checked by temp of next double equal to head. Head is nothing but uh, head is nothing but the first node address. When we reach the last node, we need to assign new node of next equal to head. As we all know that new node of next equal to head, and we assign new node address to the head variable, and temp being the last pointer variable. Temp is nothing but the last node, and temp of next points out to the head. As head is assigned to the new node, the temp of next is nothing but new node of, that is nothing but the last node. The last node next variable is stored as head, so it's nothing but it points out to the new variable. So this is the basic algorithm for insertion at beginning. So one check it out, and it's very easy to create a node at the beginning. So this is about insertion at beginning, and let's see what is insertion at any position. So there are some steps to perform insertion at any position. So as the first 3 and 4 steps are very easy and nothing but if we need, first step 1 follows, we need to create a node with a given value. Step 2 follows to check whether the list is empty or not, as we have already done at the beginning. So create a node using a malloc function and check whether the list is empty. Now the scenario is if the list is empty, then as it is we assign a new node address. That is nothing but when the list is empty, we are creating a first node. So it is common to all these 3 algorithms. So now what is the scenario if the list is not empty? If the list is not empty, then we define a node pointer temp and initialize with head. As we done in the insertion at beginning operation, If the list is not empty, we define a node temp pointer and initialize with head. Here also we are doing the same. So now keep moving the temp to its next node until it reaches to the node after which we want to insert the node. That is nothing but we need to take a for loop, and uh, we need to give the position where we like to insert the node. So we need to keep moving the temp variable until we have reached our position which we want to insert the node. So the condition is until the temp of data is equal to the location, and the location is the node value after which we want to insert the node. So by using for loop or while loop, we can achieve this step. So we need to take a position variable and we need to assign it to a for loop, and continue the loop until we reach the position point where we need to insert a node. Every time check whether the temp is reached to the last node or not. If it is reached to the last node, then display given node is not found in the lint and insertion is not possible. Otherwise, move the temp to the next node. Here, when the temp is reached to the last node, that is nothing but when we are when we need to insert at the last position and last node, then display the given node is not found in the list. As we are performing at any position, it cannot be able to perform at n position. So the given node is not found and the insertion is not possible at the position, at any position. If temp is reached to the exact node, now this is the main scenario which we want to perform. When we reach to the exact node after which we want to insert the node, then check whether it is last node or not. It can be there can be chance of being the last node too. Algorithm for insertion at any position is nothing but it can be insertion at beginning or it can be insertion at end. So we are checking whether the temp is being the last node or not. If it is the last node, then we are setting the temp of next to the new node address and new node of next equal to head. If it is the last node and we are if it is last node, nothing but we are inserting at the end position. So we are changing the temp of next equal to new node address and the node of next equal to head. That is nothing but we are assigning the head variable to the new node. If the temp is not last node, that is nothing but we are inserting the node at a given position in the middle of the all the nodes. Then we need to follow the new node of next equal to temp of next, as temp of next before temp of next points out to the before node after node, and we are inserting between these two nodes. New node of next will be equal to the temp of next. So new node of next points out to the after node which is after the temp node, and the temp of next to the new node, as temp of x points to the new node and new node of next points to the other node. So with this step we can achieve the insertion at any position. Here we are following two scenarios. We are checking the temp whether it is last node or not. When it is the last node, we are setting the temp of next to the node and we are giving the new head address to the new node. Whether if the temp of x is not a last node, if it is a middle node, then we are setting the new node of next equal to temp of next and temp of next equal to new node address. So through these 8 and 9 steps, we can achieve the insertion at any position. So this is also a perfect algorithm for insertion at any position. We can insert at beginning or at any end. It is able to create for both also. So let us see the last insertion operation, that is nothing but insertion at end. So algorithm for insertion at end. Step 1 is to create a node with a given value. As we all know, we call malloc function to create a node to create a block of memory having a data value and the next part value. We check whether the list is empty or not. If the list is empty, we are creating a first node, then set the head equal to new node address and node of next equal to null. If the node is not, if the circular linked list is not empty, and we need to define a node pointer temp and assign it to a head address. Now as we are going to insert at the end position, we need to keep moving the temp variable to the end position, and that is nothing but to the last node in the list. The last node in the list, the condition we check is that is nothing but temp of next double equal to head or not. Here head is nothing but it points to the first node. As circular linked list we discussed below, last node points out to the first node, to check whether the given node is a last node or not, we use this operation temp of next equal to head. If this satisfies, if the temp of next double equal to head, then we perform temp of next equal to new node address. As we are performing the insertion at end, we the last node of next is points out to the new node, and the new node of next points out to the head node. So this step 6 is a basic operation which we use to insert at any end. We need to assign a temporary pointer variable, and we need to assign a head variable to it, and move the temporary pointer variable to the last node. And if it is the last node, then we perform the step 6 temp of next equal to node and node of next equal to head. So these are the basic three operations which we are going to perform for insertion of a node in in a circular linked list. It may be at beginning, it may be at any position, or it may be at end. So these are the three simple insertion operations. There are several operations. It's not only insert, but it also has delete, traverse, um, merging two circular linked list, and there are many other operations we can perform. And I given the basic insertion operation on a circular linked list. So this is about the seminar topic, circular linked list. And thank you, one and all.